All right. Hello, everyone. I am your host, James Drummond with Codenvy. Thank you for attending CheConf 2016. In this session, our presenters are Dan Gross with Samsung and our very own Brad Micklea. Will share their presentation on building Internet of Thing IDE with Che. We have Che committers in the conference chat who will be doing their best to answer all your questions. If your question doesn't get answered, please feel free to contact us on our GitHub repo. Dan, you can go ahead and start your presentation.
Okay. Thanks, James. Appreciate that. So as James mentioned, I'm Dan Gross. I'm from Samsung Strategy and Innovation Center. And I'll be talking along with Brad on building an IoT IDE. So let's get started. Okay, so building an IoT IDE on Che. Well, first I'd like to actually make an announcement that's pretty exciting for us. So recently Samsung has joined the Eclipse Foundation. So this is very new. I think it actually happened at the end of last week. So we're really proud to be solution members now of the Eclipse Foundation. And this is not only for Che, which is an exciting IDE platform, but also for the Eclipse Foundation's IoT working group. There are a number of projects there around IoT that we leverage today, actually, on our IoT platform called ARTIK. And you know, we look forward to you know, collaborating and participating in the you know, the Eclipse Foundation projects for IoT going forward. So really, why are we doing it? Well, we're committed, as Eclipse Foundation is committed to really offering great tools for developers. And so that's the main reason we've joined, and we're really looking forward to it. So with that, I'd like to talk a little bit about ARTIK. What is ARTIK? And about IoT. Basically, what is this this world of IoT? So next slide. This is a site called Thingful. It's a site that tracks Internet of Things devices all over the world. And so what I've done here is removed the land overlay. And so all we see are the little dots which represent all of the things around the world. And the different colors represent different types of devices. So from environment to transportation to home, even flora and fauna. And the interesting thing to notice here is how many dots are in the oceans. We see the continents outlined pretty well, but there's a lot of dots in the oceans, which can be anything from buoys to barges. Some of the green ones are actually even sea turtles or hammerhead sharks. So really, IoT is everywhere, and even, you know, in the world of IoT, animals can be things. So this is the context that you know, we're in, and basically why we're interested in IoT. So what are some challenges? So as a developer in IoT, there are a whole number of considerations, and I'm not going to go through all these out at the moment, but you can see there are really quite a vast number of different considerations when you're building an IoT project. Everything from choosing your silicon vendor that you're going to be using the chips, to voice recognition, to industrial design. What are your cases and other things going to look like? Security, of course, is a huge concern with IoT products these days, and also, you know, even interoperability. Does your IoT solution work with other devices and other clouds? So this is you know, this is the problem space for us, and building solutions for IoT aren't that easy. So At Samsung, we introduced a platform called ARTIK to address some of the challenges with IoT. There's really a whole new set of skills that are needed to build IoT solutions. And so, we hope to make that a lot easier going forward. Samsung is one of the largest semiconductor companies in the world. We produce over 600 million products per year, and so that's shipping almost 2 million per day. And we're a global leader in memory and other other products. So we think we have what it takes to build an IoT platform. And so let's look at what ARTIK is. So ARTIK is an end-to-end platform. It first of all consists of hardware modules. So these are actual silicon and radios and memory, application processor, and storage, all built right onto the module. So right now we have a family of various modules. We have the ARTIK 0, the ARTIK 5, ARTIK 7, and ARTIK 10. And so they range from smaller to larger in terms of their capabilities. For example, the ARTIK 0 is a Cortex M4 microcontroller, so that's really an MCU. It's only got 256K of flash memory and 32K of RAM. So that's a very small device, really intended for edge nodes. We go on up to the ARTIK 10, which is really our full-featured module. It's extremely powerful. It's an octa-core processor. It has 2 gig of RAM and 16 gig of flash, which is eMMC flash right on board the module. So that's almost as powerful as some of the latest cell phones, for example. So that's enough about modules. What else does ARTIK have as part of the offering? Well, ARTIK Cloud is another component, and what we've done is introduced a service for doing data exchange among devices, and with that a rules engine that comes as part of the service that allows you to define what the rules are for all of the different devices, and as they exchange data machine to machine. So thirdly, we have a software stack, and for that Samsung is embracing open source and really looking toward to the open source community for things like the operating system, various protocols, development tools. So the ARTIK 5, 7, and 10, for example, run Linux, and we're committed to that. As far as protocols, we support MQTT, HTTP, REST, all of the sort of standard protocols for communication. And then as far as tools, we support GCC and all of the open source types of tools, and even development tools such as Eclipse. So moving on to security, this is a very important aspect of our end-to-end platform. We have security at the device level. So on the modules themselves, we have a secure element chip for doing crypto functions as well as keys. We also support Trust Zone, ARM's Trust Zone that comes on the 5, 7, and 10, and support there the Trusted Execution Environment, or TEE, as a way to write secure applications. And then, of course, exchanging data securely over HTTPS, TLS, it's very important. And then even on the data storage side in the cloud, we have very stringent data privacy policies. And so data is has ownership of the person producing it. So it's very important that we keep our data private. Finally, the last aspect of the Samsung ARTIK platform is our ecosystem. So Samsung is a big company, but in realizing that IoT is such a vast space, we can't do it alone. And so we really look to partners for technology, for doing system integration, for doing training and other types of services in order to participate in the ARTIK ecosystem. And so I think in that regard, we're building a much larger system than we could without an ecosystem. We just can't do it alone. Okay, so that's basically the platform. So some of the goals that we have for ARTIK, our main goal really is to reduce customer time to market. So there are a lot of IoT products being built and solutions being built, from industrial to commercial to smart homes, smart buildings, smart factories. And we think that we can bring some strengths in our manufacturing and design to that, to build a platform that scales. One of the challenges is that a lot of projects through our research we've discovered take 2 years or more, and teams of 100 people or so. So the question is, can we reduce those projects down to something like 9 months and maybe only teams of 30 people? That's part of our goal, and I think by building some of the platform building blocks, we can get there. And so really we're building an exceptional platform with Samsung ARTIK, and we are aiming to address all of the challenges that we saw earlier. Okay, so that leads us to Che and why we're talking here at the Che Conference 2016. Che is a component of our offering that allows us to provide great development tools. And so there's a number of reasons why Che is right for ARTIK. First of all, flexibility. So we're implementing a new workflow for IoT within the IDE, and that requires a lot of flexibility with how how you compile and deploy your applications. We also have an SDK that talks directly to our hardware, since it's specific hardware, and Che allows that SDK to be integrated directly into the tool. So next point is desktop and cloud-hosted solutions have the same source code. So this was a really important bullet for us, that if we were going to spend time developing a custom IDE for our platform, we didn't really want to do it with really two code bases, a local desktop version and a cloud-hosted version. We'd really like that all to be the same code base. Another point is that open source technology is very important to us, and Che is based on standards in that regard. Next, the platform supports all of the key languages, runtimes, and APIs that we're interested in, from C to Java to Python to Node.js and Ruby. These are all things that Che supports. Also, branding is very important to us. As we roll out the ARTIK platform, we would really like for Samsung and ARTIK branding to come through with that. And so we were looking for really nice ways to to keep the branding and the customization of that in the IDE. And so Che allows for that. You can see if you download it today that we have some ARTIK specific brand in there. And then finally, it's really good for the community to help bring IoT developers to Eclipse. And so this is a really important point. Okay, and so this is the Samsung ARTIK IDE powered by Eclipse Che. You can find out more at eclipse.org/che/ARTIK. We've really enjoyed working with Codenvy and on the platform, and we look forward to many more things to come. And with that, I believe Brad is going to show us a live demo of the ARTIK IDE in action.
Thanks very much, Dan. So yes, I will be showing a demo of the IDE. It's actually not going to be live, unfortunately. The device that I'm going to attach to is a little bit far away. It's actually on the other side of the world, practically in Eastern Europe. So instead, I've got here a nice recording. So I'll kind of explain to everyone what we're seeing as we're going. Now, again, for this demo part, there's a lot to fit on the screen. So do make sure that you're at 720p, and you will probably have to make the streaming window full size in order to really appreciate what's going on. So we're going to start at the terminal, but you can see we're at the terminal. We run the sh with the start command. It goes and pulls the latest Docker container and then boots. Now let's kind of jump forward to there we go. We're going to get here into the user dashboard. You'll see that it's pretty familiar. This looks really similar to Che, and that was, again, by design. Wanted to make sure that we could, embrace Che users who are getting into IoT, and similarly that we could take a base of IoT developers and, provide them with a similar experience that they might use for their, Java work or JavaScript work or whatever else they're doing besides IoT. Now you'll see some of the things we've done here. We've customized the dashboard so that it shows the kind of IoT appropriate stacks of Android and ARTIK. And you'll see in a second here as we come down that we've also added a number of samples. So we've got ARTIK samples, ARTIK LED, WeatherStorm, all these different sample codes. And these were code, of course, that Samsung had in their repositories that we wanted to make available through the IDE. So come down, we're going to grab all the samples, which is what that bundle is, and then we're going to go ahead and start the workspace. And this will be familiar with anybody who's used Che before. Once again, we're creating a workspace. Now, for those who are not as familiar with Che, or maybe coming from the IoT world, this is a little bit of a mind shift from where you're used to thinking. So the way Che works is we're going to create a Docker container that is going to have the right runtime and developer technologies in it for us to edit, build, and even run, if we needed, our IoT project. But I'm still going to connect to the device, because ultimately, while I want to do editing and I may even do compiling within my virtual workspace in the Docker container, I will need, of course, to run and debug on the device itself. That's going to be a critical aspect of what we do here. So let's kind of jump ahead here into the IDE. All right, so you can see some of that rebranding with ARTIK IDE there, ARTIK IDE up at the top. And now we're going to go into the Manage Devices section. So this is something that we added to the ARTIK IDE assembly. This really allows us to connect to different types of ARTIK devices over the network, over USB through ADB Discovery. In this case, as I mentioned, the device was not co-located with my machine. It was on the other side of the world, so I'm not obviously going to be using USB Discovery. Don't want to use a cable that long. So I'm going to be using Network Discovery. And you can see there that I've dropped in the host name, the port, and I want to log in as root and password. You'll also notice at the bottom it says Replication Project Folder. And that's super important, because one of the other things we did after we created the prototype was we realized we wanted to be able to rsync the contents of the workspace where the source code lives to a specific location on the device file system. And that prevented us from needing to do kind of some of the tedious things that typically you have to do with the IoT, which is, I develop my code, I write my code, I execute the binary, I compile the binary, pardon me, and then I SCP the binary over to my device and run it there. We wanted to get rid of that whole need to SCP. Just when I create a binary, it should be immediately available on my device as if by magic. In everything we're doing, to kind of hint at what's going to be talked about in a little bit later in the presentation, we wanted to bring kind of that smooth developer flow that I think a lot of people have gotten used to in a web development world of edit, things are immediately saved, they're immediately deployed, they're immediately available, they're just running right there, into an IoT world where that's not been possible before. So we set up that replication folder, drop in the correct port, and we connect. At that point, you can see the notifications. We're connecting to the device. I don't want to save the password. And there we go. There's my device. You'll see down here in the bottom left, I've got my dev machine, which is my classic Che container. That's where I can interact with my source code and everything else. And then I've got my ARTIK device, which you'll see has its own ART denominator there. And we'll see that it's actually got monitoring running at the same time. I'll come back to that in a minute. Now, we can see there's the device. We're on that terminal on the device. And now we're going to run a little example to put the time. We hit the compile button, and that's going to immediately compile a binary artifact. In this case, it's just using the default a.out, which is the default JCC. And then we run it. And after we've run it, you can see we've got the output in the console. Remember, this console, you can see that it's appearing under the ARTIK device. That console is the console for the machine. So this binary has been immediately deployed to the machine and is being actually executed remotely on the machine. And that output is being streamed back into the ARTIK IDE. So again, very smooth. You saw how rapid that was. Very smooth, very easy. Don't need to spend a lot of time, messing around with SCP and where are my binaries and did I move the binary and did I move the right binary and what if the version changed and all that other stuff. Now, if you've been using Che, you'll recognize this, of course. We're going to set a breakpoint here in my C code for this particular file. And I'm going to go up and click the debug button. I'm going to pause here for a second because one of the things you'll have noticed if you are a Che user is that these buttons are a little different. This is kind of the first implementation of where we are taking commands in Che generally. And it was really necessary, we realized, for an IoT audience. A lot of the developers really were used to a very straightforward, there is a compile button, there is a run button, there is a debug button, and they just always work with my project. And so we built those for the ARTIK IDE, where there's a constrained set of languages we needed to worry about and a constrained set of project types and locations we needed to worry about. So it was kind of a good first implementation. It helps us solve some of these problems of how do you create default compile, run, and debug commands, which is something we knew we wanted to do for everybody in Che, but allowed us to do it in a kind of simpler sandbox first. And now we're tackling it, as Tyler mentioned in his keynote, for Che 5.1 for the broader set of kind of all projects and all languages, which is a much more complex problem. So here we go. We're in the debugger. We're executing the code, and there you go. The breakpoint has been hit. And right now, we're going to go and just change the value of the return code. We can do, of course, step over, step into, all that stuff that you would expect of a debugger. We're going to end the debug session, and we should see an error because we changed the output to be an error code. And there you go. All right, so that's the debug. Now, there's some other kind of nice little things we realized we needed. With IoT devices, when it comes to managing the SDKs and the APIs that you're using, it's really important to understand whether you're using the same SDK and API on the device and in your workspace. It's surprisingly easy for those two to get out of sync, and it can be a really frustrating problem to try and figure out what's going on if they do. So we did two things. One, we made this little managing SDK panel, which allows you to quickly see what is the installed version, how's it going? And then we went and allowed you to also download any new and available versions. And the last part, we've got documentation that you can jump to. Let's kind of skip past that. What I did want to show is, see if I can find it. We have production. Yes, there we go. Production development profiles. And this is something that Dan had talked about earlier, the need to speed this up. There's a concept, of course, of a development mode when you're working on a device where you want GCC, you want debug, you want all these things. But then when you go to production, you want to pull that stuff off. You don't need that. You want to keep the device as light as possible. So we make it really easy to switch between these modes. And we warn the user each time that, hey, if you switch to production mode, we're going to yank all those convenient dev tools off the device. And if you switch to dev mode, we're going to push all those tools to the device. So it's saving a lot of effort and time. There you can see the monitoring for the product. And that about wraps it up. All right, so that's the demo. And I know we're running low on time here, so let me just quickly jump through a last couple little slides. So as I think I've shown, today we feel like we've got the very best IoT browser IDE with the ARTIK IDE. Installable on Windows, Mac, and Linux. Device discovery, management, all that stuff that we showed. So a lot of richness, really, especially for a browser IDE for IoT. But where we're really going is that we just want to be the best IoT IDE, period. We want desktop installers so that people who are used to running it in a very kind of classic desktop way can do that. We want to have it hosted in the cloud and perhaps even able to access it devices in the cloud. So you kind of have a much more unusually cloud-based workflow for IoT. We're definitely going to be integrating more deeply with the ARTIK Cloud and expanding the compatibility with other IoT technologies. Plus, we've got some really cool surprises up our sleeves. So keep an eye on things. This is really, we've just gone through GA 1.0 with the ARTIK IDE. So there's a lot of great stuff that is still coming. All right. So.
All right. Well, thank you very much, Brad. We're very excited to be working with Samsung and ARTIK and developing for them. And we're going to be shifting over to the next presentation. Brad will be presenting there too. So we're probably going to be taking maybe 3-4 minutes to start up the next presentation so that Brad doesn't have to run very fast, because if he runs fast, he'll be out of breath and he won't be able to talk. So, so give us about 3-4 minutes and we'll slide over the session. So this concludes our presentation, and Josh will begin the next session.